So we're recording now, you guys. So what you do to determine whether theta is equal to pi over 4 or theta equals pi over is a solution. So all you do is you plug this in here. And is sine of pi over 4 equal to 1/2? No. So the answer to this is no.
Whoa.
Isn't that hard?
That was so hard.
Okay. So this is a little bit different, and what we're showing you here is the graph. But cosine theta equals 1/2. So the way you could do this, if this were a calculator part of the test, which it's not going to be, okay, this is like saying y equals cosine of theta, and y equals 1/2, and seeing where those two things cross. Well, they cross here, and here, and here, and here, forever and ever, right? But algebraically, the way you do that is you look at your unit circle. Okay, watch this for my viewing audience at home. I'm going to draw a circle for you right there. And I put the center right there. And there you go. Look at that. Okay? So there's a circle. Ooh. All right. So where on my unit circle is cosine equal to 1/2? No.
Pi over 3.
Whenever this angle here is 60 degrees. By the way, this angle here is called the reference angle.
So would
Okay?
you keep pi over 3 negative pi over 3?
No, you don't call it negative. You call it positive. So here, and then again over here, no, that's wrong. Okay. In the fourth quadrant, when cosine is also equal to 60 degrees, right? And so you call this angle from here to here pi over 3, right? And then you call the next angle, what's this angle from here to here called? 7 pi over 3 now.
11 pi over 3.
5 pi over 3, okay? 5 pi over 3, because 6 pi over 3 would be all the way, right? And then you go backwards pi over 3, so it would be 5 pi over 3. And then to find all solutions, if they say find, sometimes they'll put it like this, find all solutions between 0 and 2 pi. But this one doesn't give you an answer. So if you want to find all solutions, every time I go around the unit circle, this thing is going to be 1/2. So this corresponds to pi over 3. This corresponds to 5 pi over 3. But this corresponds to the next time I go around the unit circle. So how many pi is it from here to here?
2 pi.
2 pi, because you're going around the unit circle again. So the way you would write that out is pi over 3 plus 2 pi k, where k is empty integer, k is an integer, or 5 pi over 3, 5 pi over 3 plus 2 pi k. So pi over 3 plus every multiple of 2 pi, or 5 pi over 3 plus every multiple. You follow that?
So with both of those, answer B.
Yeah, the whole answer is you have to do both of these, right? You have to do both of those answers. Okay? You're good? On
Well,
that?
how would you finish that problem?
You're done.
Oh, that's it right there?
Whoa! That's the answer here.
I like this. This is easy.
Okay. K is an integer. Okay? Any integer, meaning any positive or negative whole number. Right? 2, negative 2, so if you add 4 pi to this, you get another place where cosine is 1/2. If you add negative 2 pi, you get another place where cosine is negative 1. Okay, so let's look at the next one. Where's my picture? There's my picture. Place captured in a new page. That was it. Wait it. Alright. So you want to do this problem. And so with this one, it's kind of the same idea. I'm recording, right? Am I recording? Yeah. Uh-oh. We've been recording for 4 minutes now. Alright. So the way you do this is just like you're solving an equation. Right? And so what you do is you want to get sine of theta by itself. And that would involve first rewriting this as 2 sine of theta equals negative root of 3. And then what?
Sine theta equals
Divide by
negative
2.
3 over 2.
Divide both sides by 2. So I get sine of theta equals negative root of 3 over 2. So then on your unit circle, here's my unit circle. Thank you. Yeah. So I want to find all places on my unit circle where sine is negative root of 3 over 2. So there are places where sine is negative. Where are those two quadrants? Right? Quadrant 3 down here and quadrant 4 down here, where this reference angle is 60 degrees. Okay? This is called the reference angle. This angle that it makes with the x-axis. So this is 60 degrees for pi over 3 radians, and this is 60 degrees for pi over 3 radians. So you want to express this answer from 0 to 2 pi. So to go from here to here, how many pi's over 3 is that? 4. 4 pi over 3. So theta, sine of theta. So theta equals 4 pi over 3. And what else? How many pi's over 3 to get to here? 5 pi over 3. And then you are done, because this doesn't ask for all solutions, it just asks for all the solutions between 0 and 2 pi.
Wait, so what is the 0 or the negative pi mean?
Theta is between, so you're looking for the answers in one revolution around the unit circle. It doesn't give you, if it says all solutions, then you have to add 2 pi k to each one of those. Okay? All right. Next one. Oh, they're getting harder. Oh, brother. Why they have to give me one like this?
Oh, crap.
Hey, that's inappropriate for the video. I'll say your name 5 here. Mr. There's lots of brothers who went to school here. Football players.
What?
Okay.
How many people that is?
Okay, I won't say your name. All right. So, okay. So anyway, this one here is a little bit tricky in that what you have to do is something like this. Instead of calling this theta, we'll give it some other letter. We'll say that, okay, A.
No, we should do.
Let A equals 2 theta. Okay? And if theta, this is what you have to do. If theta is equal to, is between 0 and 2 pi, then 2 theta would be between what two things? 0 and 4 pi. Very nice. Okay? So what I have to do when I do this problem, I rewrite it as sine of A equals 1/2. Alright? And so we're between 0 and 4 pi, so this is A. A is between 0 and 4 pi, which is 2 theta. Right? You don't have to do this little substitution here. But, so where is sine equal to 1/2? Right? At nice, it's positive in quadrant 1, and it's positive in quadrant 2, not quadrant 4. Right? Positive 1/2. Yes? So what you know is that A between 0 and 2 pi is, they have it in radians again, pi over 6. And then again, when this angle is pi over 6, right? And if this angle is pi over 6, this reference angle, how far is it to here?
5 pi over 6.
5 pi over 6. But I have to look for A's 2 times around the circle. So if I go to here and then I go to here again, How many pi's over 6 is pi over 6 plus another 2 pi?
13 pi over
Nice, Austin. 13 pi over 6, because it's 12 pi over 6 more. And now add 12 pi over 6 to here.
17 pi.
17 pi over 6. But I'm not done yet. Oh, really? 17 pi over 6. Because this is 2 theta. It's not theta. So theta is half of each one of those, right? Wait, what's half of pi over 6?
Pi over 3.
Pi, no.
Pi over 12.
Pi over 12. Half of 5 pi over 6 is 5 pi over 12. Half of 13 pi over 6 is 13 pi over 12. And half of 17 pi over 6 is 17 pi over 12. And all of these angles are between 0 and 2 pi. And by doubling the domain of 2 theta, then when I find theta, the domain comes back to be between 0 and 2 pi. You understand what it is? Okay? So that's kind of tricky, knowing how to double the domain and look for all those answers, and then divide it back to get all of them.
Wait, they're all.
These are all between 0 and 2 pi, because I doubled my domain for my 2 theta, so I had to find 4 values, and then when I divide all those in half, I squish all those answers down to being between 0 and 2 pi. Okay? All right, 2 more example problems. We'll get there. So with this one, all you have to do is add pi over 2 to your answer. You could do a substitution like I did in the last case, or you could just, let's just do it that way. So let's be more creative. Instead of calling, let's call it P. Let me write P. P equals theta minus pi over 2. So the tan of P, which kind of looks like that, it's a sideways theta, is equal to 1. I don't know. That's how they do it. So where is tangent of theta equal to 1? Between 0 and 2 pi.
Not 45 degrees.
At pi's over 4. Okay, so you get theta equals pi over 4. And then again at third quadrant. Where's that?
3 pi over 4.
5 pi over
4.
Right? But that's theta, that's not phi, and I know that phi is theta, or phi is theta minus 2. So I know that theta minus pi over 2 equals both of these things. Equals pi over 4, and I'm going to put comma 5 pi over 2, right? So how do I get what theta is? Do some algebra. What do I do to both sides? Add pi over 2. So theta equals pi over 4 plus
What do you say? Theta equals pi over 4.
pi over 2.
Did you mean trig?
Oh, I'm sorry. Yeah, I meant B.
You're kind of messed up.
B. Yeah, that's B. Right. So theta is pi over 4 plus pi over 2 for 5 pi over 4 plus pi over 2, which is equal to, this is pi over 4 and this is 2 pi over 4. So that's 3 pi over 4. And this is 5 pi over 4 plus 2 pi over 4, which is 7 pi over 4. And what I should have really done is changed my domain to be between negative pi over 2 and 3 pi over 2, but I didn't do that. But these answers both within my, where I want to look for those answers?
Yes.
Yes. Okay, so that is the correct answer for that. Okay? One more.
No.
One more. with your calculator. Yay!
Wait, can we keep it on for a second?
Okay, okay, hold on for a second. Wait, I have to hit pause. So all you have to do with this one is graph these two things on your calculator and see where they cross. So what I'm going to do is graph y equals sine of theta and y equals 0.3 and see where those two things cross between 0 and 2 pi. And that would be my answer. So let's do this because it's worthwhile to show you how you would do this on your graphing calculator. And first thing you want to do is you want to make sure you're in mode. I can't see you keep this mode.
Yes.
Mode. You want to be in radian mode. Right? And let's set up a window to be between 0 and, well, 0 and 2 pi. So let's go on. I'm going to set up my window to be between 0 and 2 pi. Okay? 2 seconds. Is this pi? Pi. Okay? And since I know that sine goes from where to where? What's the highest sign to be?
1.
1 or negative 1, right? It goes from negative 1 to 1. I'm going to set this a little bigger than that, so I'm going to go like negative 1.5 up to positive 1.5. Okay? And then I go to my y equals, and then I hit clear, and then I put in my first function. Sin theta, which is now x, right? Wait,
Yes.
sin x. And y2 is going to be 0.3. And then hopefully if I set up everything correctly, if I hit graph, I get my sine graph between 0 to pi, and then I get my y equals 0.3 graph. Yes?
Yes.
And then I see where those cross. Do you all know how to do that?
Yes.
Second calc.
Over 1. Oh, no.
Oh, did I mess up? Second, first calc.
Over 2. Up 1. Up. Right. Right 1. Right 1. There.
Calc intersect. I'm going to hit that. And you go first curve, so I might have want to zoom in on that or something, but I'm going to say that the first curve is, come on, first curve. We'll call this the first curve. And I'll hit
Oh,
enter.
it's going to keep going.
Weird. First curve. There's the first curve. And then it should automatically jump to the second curve. And then you hit guess, and you want to get somewhere close to where you think they cross. Good. So the first value is, I can't read that for you. Can you read that?
304.
Let's see, we can make it bigger with our cutting edge tools.
Good place to do that too.
I didn't want to. So it looks like those intersect, so the first place they cross is at 0.305 radians, comma, 0.3. Okay, and then we can do the same thing. And that's it. That's all she wrote here. Okay, the end. And remember, you heard it here. Mr. Leader's Comedy Math Channel. Okay.